Right. So we'll start. We'll look at today cloud architecture. That's module 9 from AWS Academic Cloud Foundation. In this module, we'll look at what is AWS well architect framework is. We'll also discuss reliability and high availability. We'll look at how AWS trusted advisor can help us while following the well architect framework to design your solution in AWS cloud. Right? We have activities for AWS. We'll take sample company, a random any company, and then we'll try and apply, or we'll try and understand well architect framework design based on that scenario or sample company that we'll do in tomorrow's lab. We'll also look at a few things, which how to read the recommendations from AWS Trusted Advisor. Obviously, at the end of the lab, you will, as you have done always, you will complete the knowledge check. Right. So objectives of this module are, how just to understand and describe AWS Architect framework that includes 6 pillars. One by one, we'll look at them next, and then identify the design principles of AWS Architect framework. So design principles and best recommendation, they both constitute the well architect framework. We'll look at them. We'll also try and understand and explain importance of reliability and high availability. Identify how AWS Trusted Advisor helps customers. Also, we'll try and see how to interpret AWS Trusted Advisor recommendations. So let's start with introducing AWS Architect Framework. You can see an AWS Architect Framework, or generally architecture, is what? It's basically a procedure, architecting, you can say art or science for things to do it in a right way, if I may say, right way. As you can see in this image, you have this completed building, structure. So it starts from structural design first, and there are decision makers. So as an architect, you interact with decision maker as well as the persons or the technologies or the entities who will actually build. So that's probably a building crew, in a house case. So as an architect, you take design. Sometimes you design yourself based on the decision maker decisions, right? Or suggestions or recommendations. You design the solution and then give it to building crew, right? In some cases, you may yourself implement that design, but in other cases, in most cases, architect will then add, follow the well architect framework, for example, in AWS cloud, or any other well-defined procedures, and then give it to building crew to build the whole building or large infrastructure, right? Now, cloud architects, what they do, cloud architects engage with decision makers, which generally are customers, right, to identify what their need is, in other words, business goal, and the capabilities that need improvement, right? Then their job is to ensure alignment between technologies that will be used in that solution and the business need or business goals, right? They also do, the cloud architects also do engage with the delivery teams, work delivery teams that will implement the solution that to ensure the technology features are appropriate, right? Having this guide in a way, right? Having well architect system greatly using this guide or the framework, the systems greatly increases the likelihood of any business success rather than randomly starting building, right? So What is the AWS well architect framework? So what is the framework? The AWS architect framework basically is a guide for designing infrastructures that are secure, obviously high performing, that will have high performance, are resilient, as well as efficient, right? So basically is a procedure that ensures a consistent approach to evaluating and implementing cloud architectures, right? So basically it provides best practices that were developed through the lessons learned by reviewing thousands of customer architecture in AWS cloud. So they have they have designed this well architect framework by with experience, with the real experience that the client has faced, or some other people have designed their own cloud infrastructure. So based on that, they have come up with this well AWS well architect framework. Now it has 6, as you can see, pillars. What they call is pillars: operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. Now we look at each of them individually, right? So in general, this framework organization is you have a set of design principles. It gives us a set of design principles, each of these pillar, and best practices areas. There is an example, as you can see in this slide. Excuse me. Right? So best practice areas, right? And design principles is what AWS Architect Frameworks give us. Each best practice area aligns with questions. There are a set of questions a reviewer should ask when designing an architecture. So we should ask ourselves and find the answer. And together, those answer forms a well architect architecture, a fine architecture based on the recommendation from well architect framework, right? So you can see here best practice area, identity and access management, right? What is the question? How do you manage manage? This is just an example. There are several questions we can see, right? How do we manage? So best practices, the principle will be security here, right? The best the architecture principle is security here. This one, right? The pillar is security basically, and that best practice area in that to achieve that secure let's say architecture is one of the tool is identity and access management. How do you, and while designing the architecture, we ask ourselves, or the architect has to ask himself or herself, how do we manage credential and authentication? And then you find the answer. Answer is given here, right? Following these best practices, right? Define requirements for identity and access management, secure AWS account root user, and so on. Rotate credentials regularly, audit credential periodically, and other based on this recommendation, we come up with an answer, and that's how we address this pillar. As in there's an activity, as I said, right? We will discuss that in tomorrow's lab. So let's start with operations excellence pillar. That's the first pillar, right? As is a combination of basically design principles, and each this pillar involves design principles as well as best practice area, right? Operation excellence pillar basically is to deliver business value, right? It focuses on running and monitoring system to deliver business value and to continually improve supporting processes and procedures, right? Key topics it addresses is automating changes, respond to events, right? Defining standards to manage daily operations. The design principle involved in operation excellence as per AWS well architect frameworks are perform operations as code. Now, if you remember, in last lab, answering one of your question, I said, what is cloud? Cloud is, essentially just a large code, isn't it? Code is managing everything in the cloud. So basically, it's software. It's not technically a software, but you can envision it as a software which is managing everything. So our operations or our workload, when you identify, think it as a code. Perform operations as a code. So any operation you identify that needs to be designed, that needs to be put on cloud, we should visualize it as a code. In that code, we keep making frequent, small, and reversible changes as well as per our need, isn't it? Once we come with an operation, once we come with an architecture, we need changes. Obviously, there would be there would be situation where we will make changes. That changes should be reversible. So basically, designing workloads to enable components to be updated regularly, make changes in small increments that can be reversed if needed or if they fail, right? Without affecting the uh, the real clients, right? For example, if you have hosted a website, right, you want to make, you have to make changes. Probably you will make those changes, small, frequent, and small changes. Again, frequent and small would be as according to the need, but you should have an design and a development environment where you can make those changes, conform all those things. First, obviously, in regular industry practices, you have development environment, and then you test everything there, and then you go to production environment. But we should do that in a way that even if it doesn't work for some reason in production environment, it should be quickly reversible. Next principle is refine operations procedures frequently, right? So we should always strive or look for an opportunities to improve the operation procedures, right? We should try and evolve our procedures appropriately as the workload evolve as well. Should set up regular game days to review all procedures, validate their effectiveness, and ensure that the teams are familiar with them. We should always anticipate failure, right? So once we anticipate, how do we anticipate failure, right? So what could fail? Well, as you can see in later slides that, the AWS has been designed, the whole AWS has been designed with the idea that everything can fail. So once you anticipate failure, identify potential sources of failure so that they can be removed or mitigated, or they can be repaired, based on what type of failure, what component has failed, and something like that, right? Test failure scenarios to validate the understanding of their impact, right? And then if there is a failure, you need procedure to handle that. Incident handling, right? Incident procedure handling. Some of these things we did in, at least we got introduced, just we did one lecture, but something we got introduced in InfoSec 2. So how do you, it's failure. Basically, we're talking about failure here, but failure is also an incident, isn't it? Right? How do we handle? So we should have proper plan and procedure to handle that, right? And that procedure also should be tested periodically to ensure their effectiveness, that that and others who actually handles this system should know how to follow those procedures in terms of whenever the failure has occurred, right? Now obviously it's like takeaways, we should learn from all operational events and failures, probably, to get our procedures, recovery procedures, and other things improved. Right here, you can see operation excellence question. So that's in best practice areas in operation excellence, right? You try and answer these questions. So the foundational question of our operation um, excellence falls under four categories, as you can see. Organization, which is how do you determine what your priorities are? How do you structure your organization to support business outcomes? How your organization culture support your business outcomes. Next is to prepare based on the organization. How do you design your workload so that you can understand the state and meaning? As you can see, there are a few more questions which follows. So basically, we try and answer, or an architect or whoever is responsible to follow or to design your cloud, to put your workload, the design in cloud should answer these questions. Based on this answer, the design should be done. How do you reduce defects, ease remediation, and improve flow into production, and many other questions. Third, you can see the third design principle, or third question is not design principle. Third category, you can see our best practice area is operate. How do you understand the health of your workload? How do you understand health of your operations? How do you manage workload and operation events? You will have an answer for these questions before you actually do that. Finally, it's important to design operations that evolve in response to change and to incorporate lessons learned through their performance. So that's operation excellence, right? This is the activity, one of the slide. You can see I have given the slide. We will carry out in lab tomorrow, right? The next pillar is security pillar, right? So the focus of this security pillar is basically to protect and monitor systems, right? Basically, the aim here is to improve the ability to protect information, systems, and assets while delivering business value through the risk assessments and mitigation strategies, right? Key areas involved here is protecting confidentiality and integrity of data, whether in transit or at rest, right? Identifying and managing who can do what, protecting systems, as well as establishing controls to detect security events. Now, the design principles there are in security pillars are: first, you implement a strong identity foundation, right? So implement, basically it involves implementing the principle of least privilege. Let me again point you to my InfoSec class, previous class, or any other class where you have learned about principle of least privilege. It's in a very simple sense. It only says that give one access to an entity or person or or a computer or whatever, the least access, the least possible access that that entity needs to do their job, whatever job it is doing, right? So always go for the least possible access rather than maximum possible access, right? So least privilege principle. So implement basically least privilege principle, right? A principle of least privilege, as it popularly known as. Enable traceability, right? So there should be a mechanism to audit, right? To read logs, monitor, alert, and audit actions and changes to the environment in real time, right? There should be mechanism to integrate logs and metrics with system to automatically respond and take actions if something goes wrong. Apply security at all layers. Now, for each and every layer, you apply security. Remember, defense in depth, right? So we should implement the idea, the principle called defense in depth, right? For example, I would say when you create a VPC, right? We have been doing that so many times in this course in labs, right? If you create a VPC, you should implement security at VPC layer. I mean, at VPC level, then at subnet level, for example, NACL, right? And then at resource level as well, right? At resource level, if you add an EC2, add a security group for that, right? Inside the EC2, if you are running an application, you should add another layer of security for that application itself, right? If you have regional resources which spans across region, you will probably think of some security layer there as well, right? So every component, I mean, when we say every component, not every component, but every layer, if we are making a layer using those components, the layer consists of a few components, then that's fine. Implementing a security layer, a security idea, or depending on what you are talking about, right? You would implement that for each of the layer. So each one layer could consist of few different components. You can have one security construct for the entire layer, right? So when we say difference in depth doesn't mean that we implement separate, unless there is a need, we go and implement, or we go and construct or design a security component for each of those resources, right? By layer, but each layer. So basically, for VPC, if I just put an ACL for a subnet inside a VPC, I should not be saying that, oh, everything is secure. What about security groups for the EC2 running there, for example, a web server? It's always good to automate security best practices as well, right? Or automating security mechanisms to improve our ability to scale more rapidly and cost effectively, right? So the idea is to create secure architectures and implement controls that are defined, maybe managed as a code in version control templates, right? Protect data in transit and rest. We know we can use encryption, for confidentiality, for authentication. The newer ideas are using tokens. Previous ideas are also and access control mechanisms wherever it is applicable. Next, you can see keep people away from the data. Now, this keep people away from data would mean that, the idea is to reduce actually human errors, right? Risk of loss, modification of sensitive data, or, for exposure of sensitive data due to human error. The mechanism should be placed there. Mechanism, obviously, and tools, technologies, whatever technology, like for encryption, you'll use encryption technologies to reduce or eliminate the need for direct access or manual processing data. So basically, automation here as well. Prepare for security events as well. We should have incident management system. Again, I'm referring to previous class. Incident management system that aligns with organizational requirements, right? We should always have, like sometimes we get a drill. When I'm lecturing, or when we are in class, suddenly the fire alarm sounds and we all have to get out. It's just a drill. The similar things we should plan as an incident response. So drilling should always happen there, as in if some kind of incidents occur, what to do. The procedure should be there, definitely, and we should do simulations as well, right? Use tools with automation to increase the speed of detection, investigation, as well as recovery. So this is security design principles. Now you can see these questions here, right? So the foundational questions for security fall under these 6 categories, or 6 best practices area, right? So security first, how do you securely operate your workload? Now this is a generic question, but it will probably include most of them, most of the solution, depending on your workload, what you are going to do. You would then look for identity and access management, which will deal with giving accesses, roles to people or resources. So how do you manage identities for people and machines, right? How do you manage permissions of people and other machines? So you should plan, Answering this question means you are planning, basically. Detection, well, how do you detect and investigate security events? Obviously, incident management comes here into picture. Infrastructure protection, how do you protect your network resources as well as compute resources? Data protection, how do you classify your data as in, least sensitive, most sensitive, fully and highly confidential, whatever category you can assign depending on what kind of data you have. How do you protect data at rest using encryption mechanism? Maybe how do you protect your data in transit? You can use cryptographic protocols like TLS, or if you want to implement IPsec, that's fine too. Again, this is nothing to do with the cloud or cloud architecture we are running, because we are related with security and something. So I keep on giving examples. When I'm referring my previous class, if you are not in my previous class, you should not feel that okay, I'm referring the old content here. I'm just giving an example. It has nothing. It is not directly related to the course we are doing currently. Again, incident response. Should anything occur, how do you anticipate, respond to, and recover from incidents? So that's for the security pillar for cloud architect. Again, will AWS will architect framework, right? This activity again will come under when we'll do tomorrow in tomorrow's lab. We'll see that. Next is reliability pillar, right? So the reliability pillar focuses on ensuring a workload performs its intended, that's what reliability is, isn't it? Intended function correctly and consistently when it is expected to perform, right? Key topics, key areas include here is designing distributed systems, recovery planning, and handling change, right? Designing distributed system means, you should have multiple components, redundant components, right? Redundant resources. And depending on your business need, even workload, the job which is required to do to meet your business goals can also be distributed. Not only one component is doing the entire job. One is to have replica, another is to divide, that's a distributed system, right? You can have multiple nodes which will communicate with each other to achieve that goal, whatever the goal is for particular business need. Recovery planning, if something goes wrong, obviously, how do you recover, in a planned way so that the effect is as minimum as possible, right? If there's a change, if there's a need to change something, how do you change? Change of technology, change of hardware, change of the resources like EC2, if you are using M3.large, for example, and suddenly you require M4.large, something like that. How do we handle that, right? Design principles, as you can see here, includes test recovery procedures. Basically, we should always test how system fell and validate the recovery procedures. So maybe, simulate that, if the system is failing, how we can recover from that, and the recovery procedure which is there, is it enough to minimize the after effect of a failure? A good idea is to use automation here as well. Automatically simulate different failures, or to create scenarios that would lead to failure, right? This practice obviously can expose failure pathways that you can test and rectify before a real failure scenario. Now, automatically recover from failure. So you should use, for example, CloudWatch events, right? That will give you an idea to monitor system for key, From CloudWatch, you can see key performance indicators and configure systems accordingly to trigger an automatic reveal. First, it will trigger obviously an alarm and all those things, right? Automatic, you can put in a place a design which will then be triggered, for example, with lambda function, automated recovery when a threshold is breached, depending on what you call the fail. For example, if my web server is not responding quickly as our threshold, whatever we have said, then go for other web server, whatever failure scenario you have, whatever recovery scenario you have, right? This will definitely help us automating notifications, failure tracking, and for automatic recovery for processes that work around or repair the failure. Next is to scale horizontally to increase aggregate workload availability, right? So the idea here is to replace one big resource with multiple smaller resources and distribute requests across these smaller resources, right? What will happen then? It will reduce the impact of a single point of failure on the overall system. So basically, it's designing distributed systems. So you divide the workload and give those smaller jobs to multiple components, so that if a component fail, it will not hamper the entire system. Obviously, for that failure, you'll have recovery procedures in place as well. Next is stop guessing capacity. So we should have a real statistics to monitor, right? You can use CloudWatch or any other things to monitor the demand and the system uses, and automate the additional or removal, auto scaling, load balancing, all those things we saw in last class, right? Removal of resources to maintain the optimal level of satisfying demand, right? Again, manage change in automation, automate everything basically in cloud. Use automation to make changes to infrastructure and manage changes automatically. This is what reliability design principle tells us, right? So questions. So the questions related to reliability falls under broadly four best practice areas. One is foundation. So to achieve reliability, right, we should be answering this question before the design, for example, to help us in design basically, right? How do you plan your network topology? That's for foundation, right? How do you manage services and quotas, constraints, all those things? Workload architecture. Within workload architecture, how do you design your workload service architecture? How do you design interaction in distributed system to prevent failure, and so on. Next, best practice area is change management, right? How do we monitor workload resources? If there is change required, how do you adapt the changes in demand? How do you implement the change? We say it should be happening. We should apply automation here. Failure management as well. So there are a few questions. Backup. How do you design your backup? How do you use fault isolation to protect workload? Or even if that is needed, we don't have to answer each of these questions before designing, but if these questions are applicable or not, right? How do we design workload to withstand component failures, and so on, right? How do you say that the system is reliable? How do you plan for disaster or disaster recovery if there is any catastrophic event occurs, right? So performance efficiency pillar. Next is the performance among six, which basically focuses on the ability to use IT and computing resources efficiently to meet system requirements and to maintain that efficiency as demand changes and technology evolve. Now, key topics or key areas that performance efficiency pillar addresses is selecting the right resource type and sizes based on the workload requirements. And this is the first thing we probably did in lab in second or third week, right? We actually, that was basically cost focused, but we had certain resources and we looked for the cost, what that cost will cost. That is also a thing to look at when we determine resource types, right? First thing is what type of workload we have, and based on that we select resource types. Then we think about cost of optimization as well, right? Monitoring performance, that will definitely help us give some insights into how we can improve the efficiency of performance, efficiency of the researches we have done, efficiency of the application we are running, and then making informed decision to maintain efficiency as business evolve. Again, we need to have statistics, right? Data to make informed decisions, and data we know where can we get it from experience, for simply experience, or we can use AWS tools such as CloudWatch, other those, and there are various metrics there to make informed decisions. Now, performance efficiency design principles, there are basically 5, as you can see, right? So democratize advanced technologies, right? So in AWS cloud, we should treat technology as consumers or consuming, right? Consume technology as a service. Now, for example, technologies such as NoSQL databases, like we looked at, but we didn't do much because we are not familiar with that much, right? We did an exercise with RDS, but not with NoSQL databases. Machine learning, AI requires, basically expertise that is not evenly dispersed across the technical community or your team. You don't expect everyone to know those things, right? In the cloud, these technologies become services that teams can consume, right? Consuming technology enables teams to focus on product development instead of the resource provisioning and management. So basically, in simple sense, what we are saying is the team who is working may not know advanced technologies, which in IT everything evolves every day, almost every day. We can't keep up with that. Newer technology we may have not seen as well. So treat them as a service, consumer service, right? Teams can work with that technologies without knowing them, right? We should make an environment like that, or we design like that. Grow global in minutes. So deploy systems in multiple AWS regions, right? Or based on latency. Remember, we looked at a website. I don't remember that website name, where we can see the latency based on, and obvious thing would be the closest region we deploy our resources, right? Which will minimize the latency, have lower latency, and a better customer experience at minimal cost, right? Cost is also a factor. Where applicable, use serverless architecture. We have looked at Lambda. We have looked at the web, AWS, I forgot the service name, which directly give us web server. We can simply deploy your code and there's web server, right? Other ways to install your web server, other applications in a EC2, like virtual machine. You can use that. Other ways to use serverless architecture as well as managed services, which makes our job easier. Now, serverless architecture can also lower your cost, right? Because managed services operate at cloud scale, right? Scaling, you don't need to worry about it. Automatically scale those management services, and you are focusing on your application development, your business needs, rather than maintaining these servers and having people to look up these servers and worry about many things that is related to hardware or server. We should always keep experimenting. it should be as often as possible. We should have comparative testing, something like that, of different resources. That would include storage, different storage we have, EBS, EFS. We looked at, right? Even simple storage, right? S3, simple storage service like Amazon S3. So comparative, depending depending on our workload, which will perform better in our given scenario. Consider mechanical sympathy. Considering mechanical sympathy, that is using technology approach, technological approach, I should say, that aligns best with what we are trying to achieve. For example, we can consider our data access pattern when we select approaches for databases or storage. So which database is best for us, right? Depending on our access pattern and other things, right? Now, the questions which falls under performance efficiency pillar is, there are 4, you can see: selection, review, monitoring, and trade-offs. So basically, these 4 best practices area. Now, within selection, you can see, right, how do you select best performing architecture, how you have selected, basically, how do you select your compute solution, similarly for storage, database, or networking solution. Once you select, you should review as well. How do you evolve your workload to take advantage of new releases, right? Monitoring, how do we have a continuous kind of monitoring the resources, mechanisms to resource as to ensure how they are performing, or even if they are performing up to the standards we expect, right? Finally, how use trade-offs, in architecture to improve performance, such as using compression, caching, or relaxing consistency requirements. So that was for performance efficiency pillar. Now we have the last one, cost optimization pillar, right? So cost optimization pillar in AWS well architect framework is to eliminate unneeded expenses. So basically, the focus is to avoid unnecessary costs. Now, key topics here is understanding and controlling where the money is being spent. We have looked at cost and cost management now the third week or second week, right? Selecting the appropriate right number of resources types, appropriate as well as right number, right? Analyzing spend over time or fixed period, or but it should be continuous exercise, and scaling to meet business needs without overspending, right? Now, the key design principles or cost optimization principles, you can see: implement cloud financial management based on AWS cost management and other guides to achieve financial success and accelerate business. Value realization in the cloud will need to invest in cloud financial management and cost optimization, right? Basically, to build capability through knowledge buildings, programs, resources, and processes to become cost efficient organization, right? We should look to adopt a consumption model, that is, right? Pay only for computing resources that we actually require, and then later increase or decrease uses depending on the requirement we have, workload, and our business goal, right? We should not have like elaborate forecasting and immediately increase or something like that, right? But based on our uses, we should make these decisions. We should look to measure overall efficiency, so measure the business output of the workload and cost that are associated with delivering it, right? Now, we can use this measure to know the gains that we make from increasing output and reducing cost, right? Stop spending money on undifferentiated heavy lifting. That is, excuse me, AWS will do all your heavy lifting job. For example, racking, stacking of your servers, or powering your servers, which means that we can actually focus on our customer, our business need, our business project, rather than the IT infrastructure. Analyze and attribute expenditure. The AWS makes, in some ways, in many ways, easier to accurately identify system uses and costs by following various services such as CloudWatch and other things, and attribute the IT cost to individual workload owners, right? Whatever, if there is a team which is handling, we can attribute the cost to a team there, depending on what workload we have, what job we have at that time, right? Or in particular business. Having this capability, right, help us to measure something called ROI. Remember again, right? Return on investment, and gives owners an opportunity, give owners to opportunity to optimize the resources and reduce costs, right? ROI, return on investment. We did an exercise again last year, right? So these are fundamental or foundational question of cost optimization, which falls under these 5 areas. You can see, right? Practice cloud financial management. So how do you implement cloud financial management? These questions we need to answer. With that answer will help us, minimize cost or optimize to meet cost optimization pillar, as so to say. Expenditure and uses awareness, right? How do you govern uses? How do you monitor uses and cost? Decommission resources if needed. We should always look for cost-effective resources. So how do you evaluate cost? And when we select services based on what you actually are evaluating the cost, right? How do you meet cost targets when we select resource type, size, number, right? Can we use pricing models to reduce cost? Those things we need to answer. We need to be prepared of, right? How do you plan for data transfer changes, for example, right? Another best practice area is to manage demand and supply resources. How do you manage demand and supply resources? So we should have answer to that. How do you evaluate new services? Also, that is for optimization over time. Now, there is a tool called AWS Work Architect tool, which basically automates all these questions in a way, to help us design well-architected architecture, right? So help us to review the state of workloads and compares them to latest AWS architecture best practices. Also, this tool gives us access to knowledge and best practices used by AWS architects. That's the other architect, right? How they have done. This tool is available in Management Console, right? AWS Management Console. We define our workload and answer a series of questions in the areas of the 6 pillars we looked at, namely operation excellence, security, reliability, performance, efficiency, and the final one was cost optimization, right? This tool then gives us a sort of action plan with step-by-step guidance on how to improve the workload for cloud, right? This tool provides us consistent process for us to review and measure our cloud architecture, right? The results provided by this tool can be used to identify next what we do next, obviously for improvement, drive architectural, take architectural decisions, and bring architecture consideration into the governance process or governance process, corporate governance process, right? Section 1, key takeaways. The AWS Well Architect framework provides a consistent approach to evaluate cloud architecture and guidance to help implement designs, right? The AWS architect framework documents, you see, set of design principles and best practices. So it gives us, design principles. Based on that, you have best practices area. Basically, those best practices area, the categories in best practices area contains a few questions that enables us to find particular solution, particular close to best solution for our need, right? To understand the specific architecture align well with cloud-based practices. Organized into 6 pillars, we looked at each pillar. Each pillar includes its own set of design principles and best practices, right? Before going to section 2, any question? So this is the tool we were talking about, right? IT architect tool or AWS that I mean, there is a theoretical things which we discussed. Now we can play with this tool depending on. We should have some scenario though to play with this tool, but yeah, just to look at where this tool is. Okay, so you may not have this thing in your sandbox. So if you have this free tier account, you can actually, what happened? Yeah. Yeah, AWS well, you can search from here, or because I had recently visited that before this class, I can see here. Right now, you can see these, the thing we just discussed, pillar of operation excellence, security, reliability, these pillars, performance, efficiency, cost, optimization, as well as sustainability, right? Sustainability we didn't look at. We'll look in the next section. Identify the workload to review. First step is the answer is then answer a series of questions about your architecture, the questions we looked at. Well, in this tool, not that looked at, that's the theoretical when we do theoretical design, so to say. AWS architect tool, review your answers against 6 pillars established by well architect framework. So these are the framework, right? Then you can get videos, documentation related to AWS practices to help us actually design, which includes this pillar, our architecture. Generate a report that summarizes your workload review and view results of your workload review across organization in a single dashboard, right? So other resources are there to review what we just looked at. What is AWS well architect tool. We have FAQ and partners as well, who usually gives data or design the well architect framework. Now, if you do that right now, you start why does AWS need this data? How this is how they will look at data, right? So you can define a workload, like you can define a unique identifier workload, any name here. You put some description, review on a primary individual or group that owns this review process. So basically your manager, whoever, right? It depends. What is the environment here? Is it pre-production or the real production environment, right? Which AWS regions you would like to work on? You can try. You can just give some random data and try yourself, right? If you are using any particular regions. So if you have components which will not go in cloud, that's basically non-AWS regions. So basically that type the regions outside of AWS in your workload runs. For example, if you still want to keep some of your resources on premises. Remember, while in network content delivery, we looked at various services, various ways to connect. Those gateways we looked at, which will help you connect your on-premises resources to the resources in the cloud, right? If you have that kind of architecture, that kind of need, you want some data not to go on cloud or something like that, right? So you would give that those regions as well. From, for example, Wellington region we have, and we may have chosen, if your office is in Wellington, on premises service, some of these servers are in Wellington, and if you randomly choose, for example, Singapore region, they will suggest you that it's better to choose the Sydney region, or better even um, the Auckland region, which recently has opened, right? Account IDs, which account IDs, type of IDs that AWS accounts, account workload span across, right? So like I have this account ID, I'm the root user, so I'll give my account ID, or depending on other account ID you say, right? Application optional, it's application custom resources, metadata, or the tags. It's optional thing, but if you have, you can do. Again, design, a link to your architect design previously. If you have designed in architect design, you can give the link as well. Right? Should follow these protocols, so basically hosted somewhere, and you can do that, right? Industry type, again, what kind of industry you have, industry, then, and then are you using it activated AWS trusted advisor as well, which we are going to look at next today. What is this? And then you will just do next. I have not put any data, so I have to put some data, random data here, and you keep on doing next, answering this question. Finally, you'll get a dashboard with recommendation in a way for your workload, whatever kind of workload you have, and then you go through. After that, you go through and check if you have met all these sort of requirements for all to meet all these architect framework, architect framework, right? So we can actually do by pen and paper, or in your computer, or follow this tool to design architect architecture in AWS. So section 2 we are looking at today is within reliability and availability within cloud, the module line cloud architecture. Right, you can see a quote here. Everything fails all the time. It's from Werner Vogels, Chief Technical Officer at Amazon, or Amazon.com, right? In his words, everything fails all the time. So one of the best practices that is identified within AWS well-architected framework is to plan for failure. So failure of application, services, components, resources, or workload downtime, right? One way to do that is to architect applications, the resources we need, or applications we run, and our workloads to withstand failure. So there are two important factors you can see that cloud architects should consider when designing architecture is to withstand failure, is reliability and availability, right? Reliability, basically it's a measure of our system, or system's ability, that is, ability to function or to provide functionality when desired by user, right? Because the principle, the quote we just looked at, everything fails all the time. We should think reliability in statistical terms. Reliability is the probability. A system basically includes everything, you see, right? Components, that is system, hardware, firmware, software, other things, sometimes human failure as well. We should measure it in statistically, right? The reliability basically is a probability that your entire system will function as intended for a specified period. One of the statistics which is used to maintain measure reliability, so to say, is mean time between failures, right? Total time in service divided by number of failures, right? To understand reliability, let's look at this example, right? a car. You can see a car has a car is basically a system, right? Each of us may have our own car. Each of these car components, for example, cooling, ignition, and brakes, as given in this figure, must work together in order for car to run or function properly. If we start the car and ignition fails, we can't drive, right? The car is not available, not reliable. If ignition fails repeatedly, the car is considered not to be reliable, right? The common matrix is, as we said, mean time between failures. What is this? We'll look at now, right? So mean time between failures is calculated as, for example, let's say our car was, on our system, let's say not car, but our web server, we have a web server, and we configured everything and to optimum standards, and we brought that web server online on Monday, let's say, right? Monday noon or something. And it ran until, without failure, without any problem, until the Friday noon, for example, right? But somehow it failed on Friday noon. And then, you or, engineers who were looking for web that are responsible for web server spend it full weekend to fix that. And again brought the web server online on Monday, right? So your system was available for 5 days, say 96 hours, right? And it failed on weekend, and you spend whole weekend to fix that server, um, um, and that constitute to, for example, 90 or 72 hours, right? So, right, this happened repeatedly, right? So you whole weeks, the system is available. I'm just giving a random example, right? Um, the system could be available one day, another half day, a few hours you take to fix it. Again, it failed, right? For some hours. So you calculate average, right? You calculate average of time to repair if these things are happening repeatedly, and the average time it was actually working or system was available or online. Now, mean time between failure is MTBF, as you can say, is MTTF plus MTTR. MTTR is mean time to failure, right? Which is time, which includes time that took to bring it back to online after a failure, and mean time to repair, MTTR is, sorry, I got confused. Mean time to repair is basically MTTR is the time you took it to repair, which is basically, whatever time it was. If it was failed over the weekend, and you took that, it could be 72 hours. And mean time between failure, between failure as in time, your time, mean time as in average time to failure was MTTF, right? Which if it ran for the whole week, probably 96 hours. Or if it was online for the whole day, it is 24 hours. So you simply calculate averages of when it was online, the whole time it was online, as well as the time it took to repair. That is, it was the time when the system was not online, and you add that up, right? So that's mean time between failures, MTBF, right? Availability and reliability is measured in terms of MTTF, as we said, right? MTBF, that is mean time between failures. Availability is basically normal operation time divided by total time, right? So if your application was available whole year, less one day, and it failed for one day, right? So we simply divide the whole year by the time it was not available, right? It is also defined as a percentage of uptime. For example, 99.9% time over time, for example, for a year, for period. That's for a specified period, generally in terms of year. The percentage of uptime over the time specified period, which is generally an year, right? There is also a shorthand to describe availability by number of nines. So if you say 5 nines means 99.999% availability, right? Right. So when we say a system is highly available, what does it mean? It means that system can withstand some measure of degradation while still being available. Now, it is the business of decision, depend on what kind of business you are running, right? To find that acceptability, right? The measure of degradation. The system can degrade, but still is available, right? It is acceptable degradation of your service, you know, that comes also into a factor, right? So in other words, you can say a highly available system can be viewed as a set of system-wide shared resources that a business or office utilizes to guarantee essential services, right? Um, Highly availability also combines software with open standard hardware to minimize downtime quickly by restoring essential services when a system component or application fails, right? So basically, if a system is available after a failure within a minute, that is considered acceptable, sort of acceptable, right? For some system, even going offline for a second, a minimum, or less than a second is also not available. But in general, if a system withstands a failure for 1 minute, that is, backup system, whatever redundant system you have kept to put back online, the system online or serviceable again, ready to provide services within a minute, that is a standard time. We can say that the system is highly available. Now, availability tiers. So, the requirements vary, right? You can see in this slide here. So when we say 99% availability, it could mean that 3 days, 15 hours maximum distribution per year across a few years, right? Application category, batch processing, data extraction, data transfer. These are considered 99% available if the failure is limited to 3 days, 15 hours. That is within a year. On average, we are saying. When we say 99% 9, that is 8 hours, 45 minutes, right? Internal tools like knowledge management, project tracking, other things. 99.95, you can see maximum acceptable disruption per year is 4 hours, 22 minutes. It's for applications like online or point of sale, right? Those kind of applications. 99.99, you see video delivery and broadcast systems would be available for 99.99, right? Now 99.59, that is 99.999, it's basically 5 minutes per year. It's for ATM transactions, telecommunication systems, and other things. Now these can vary, right? The length of disruption that is acceptable depends on type of application. But that's a general consideration, right? The general consideration which we just looked at, right? For these applications, 99%, and for these applications, 99.999. Now, factors that influence availability are, broadly three categories, falls under three categories: fault tolerance, scalability, and recoverability. Now, fault tolerance refers to the built-in redundancy, basically, right? The built-in redundancy of an application or applications components components and the ability of the application to remain operational even if some of its component fail, right? Fault tolerance relies on specialized hardware to detect failure in the system components such as processor, memory, power supply, input, output systems, or even storage. extra storage subsystems like EVS, in terms of AWS cloud, when it comes to AWS cloud, right? And if a failure happens, it should automatically switch to a redundant hardware component. The fault tolerant model does not address software failures, which are the most reason for downtime for most of the services. Scalability is the ability of application to accommodate increases in capacity need without changing the design, right? So basically, it means that to remain available and perform within the required standards or your acceptable limit. What again, it depends on an application. Even there is some failure, right? Or even not failure is for fault tolerance, but for scalability, it's sudden increase of traffic. In those cases, it's the system is servicing the needs of clients, customers within the acceptable limit, which is acceptable limit of degradation. We say, the speed may be slow, but is it still acceptable, right? It does not guarantee availability, but it does contribute to the application overall availability, right? Scalability. Recoverability, you can see it's the ability to restore service quickly and without loss of data, traffic, whatever it is, if a disaster makes the components or server services unavailable, right? Or something happened that destroyed the data after a catastrophic event, right? Section 2 key takeaways. Reliability is a measure of the system's ability to provide functionality when desired by the user. And it can be measured in terms of MTBF, mean time between failures, right? Availability is the percentage of time that a system is operating normally or correctly performing operations expected of it, or normal operation time over the total time. So 99.999% available, something like that. That's how we measure it, right? There are few factors that influence availability, which are fault tolerance, scalability, and recoverability, right? We can design workloads and applications to be considered highly available, but there is a cost trade-off to consider, right? So designing highly available systems incur costs, right? Incurred costs or basically it increases cost, right? When we consider how to make our environment more available, it is important also to consider how to get the balance between the cost of improvement with the benefit of the user. That's why we were mentioning a few times like acceptable to the acceptable limit, right? And we saw that as well. So increasing high availability will increase cost as well. Now we have to find a balance between increasing cost and high availability, right? Next we are looking at next thing we are looking at is something called AWS Trusted Advisor, right? So basically, AWS Trusted Advisor is an online tool like we had. I showed you AWS Architect tool. Well Architect tool is an online tool that provides real-time guidance for us to provision the resources following AWS best practices. You can see it looks at entire AWS environment and gives us real-time recommendation basically in 5 categories. See, custom optimization, performance, security, fault tolerance, and service limits. You can see there's green would mean, yeah, it's okay. Everything is okay, but you have some recommendations, right? This the triangle shape with exclamation mark means some alerts, right? Red with exclamation mark means something is wrong. We need to fix it, right? So within cost optimization, performance, security, fault tolerance, and service limits, right? Here, there's an activity, right? Mm, which is we have time, we can do it now, or we can do in lab. Activity: interpret AWS trusted advisor recommendations. So we can use AWS trusted advisor tool. If we enable that, it will, while implementing your architecture within the architecture itself, while creating architecture using AWS, the tool, a well architected tool, it will give us some recommendations depending on what we are doing, right? So here, interpret AWS trusted advisors recommendation. You have trusted advisor dashboard. You can go there and see what we have, right? So green would mean basically that everything is okay. And others are alerts. Some are must do thing. You can see red here. The cost optimization, you can see here, right? Is everything is okay for cost optimization in this case, but for others, you see, there are a few things we need to review to help improve security, performance, and fault tolerance here. In service limit also we don't have. Now, let's see activity 1, that is recommendation 1, MFA on root account. Now, this is for security, right? So you will get this kind of recommendation, right? So description checks the root account and once if multi-factor authentication is enabled or not. MFA on root account, that's the thing, right? For increased security, we recommend that that's the recommendation we have. You protect your account by using MFA, which requires a user to enter a unique authentication code from their MFA hardware or virtual devices when interacting with the AWS console and associated websites. All the criteria: MFA is not enabled on the account, recommended access, log into your root account and activate MFA device. So this kind of recommendation we get from AWS trusted advisor. If for in this case, what is the status? Status is red here. We should do that, right? We should, in a way, we must do that. Now, what is the problem? The problem is we have not enabled, the architect had not enabled multi-factor authentication on root account, which we must do. How to do that? Right? Log into your root account, activate MFA device, whatever device you are. I'm using my phone, the app, MFA app, which is on my phone, and there are a few other options as well. That's the recommendation, right? Now, let's look at another, right? So recommendation. Now, what is the status here? Anybody? Status is yellow, right? It's kind of, you should do. It's not red, you must do, but it is, you should do, sort of that yellow, right? We drive the car, isn't it? Yellow is for if you can stop, isn't it? Red is you must stop, something like that. Same analogy here as well. So here, IAM password policy, right? What is the problem? The problem is a password policy is enabled, but at least one content requirement is not enabled, right? What is the specific environment details that we have given, the entire description here, right? Description checks the password policy for account, and once when the password is not enabled, whatever, or if the security of your AWS environment if password contents have not been enabled, password contents requirements increase the overall security of AWS environment by enforcing strong user passwords, something like that, right? IAM, it's about IAM password policy, and this description is there. You have recommended action as well. If some content requirements are not enabled, consider enabling them. If no password policy is enabled, create and configure one. See settings on password for IAM users, right? Similarly, you have a few other recommendations. Recommendation 3, security groups, unrestricted access, right? So you have given security groups unrestricted access. You see, this is unrestricted as access range, right? at this point, I would also like to tell you, in your assignment, you can do that, right? You can use this for SSS or HTTP access. But for SSS access, this is SSS access, isn't it? Port 22, right? Status is red. We should not give anywhere. That's called anywhere IPv4. When we go and select that option from anywhere sort of thing, we should never do that. But for your assessment purpose, you can do that. I put that recommendation there as well, because you probably will be behind NAT and your computer has a private IP rather than a public IP, right? So we can, while doing at home, even at campus, right? So at campus, I can help because I know the NAT address and everything. So to give you a particular IP, which we can create a bridge, a tunnel, or something like that. But at your home, I can't. So basically, you can put it 0000/0. That means everything is allowed, or every IP is allowed to SSH into your web server. Yeah. For your database server by web, 8080 is web, you are going to access, and they are giving you a sort of warning, right? So description, unrestricted security groups, unrestricted access description is there, alert criteria. You can see a security group will has IP address with suffix, /0 for ports other than 2580 and 443. This is not good. Yeah. Now, you may, in your final exam, you may get this kind of scenario and some questions based on this, right? So we should take it seriously. I'll just stop the recording. We have a few more slides, a few more activity basically, which we can continue in lab where I can interact with you. Because when I'm asking question, you're not answering. So it's better we put in lab, and face-to-face, you will interact with me. Now, key takeaways. Section 3, AWS Trusted Advisor is an online tool that provides real-time guidance to help us to provision resources by following AWS best practices. We previously looked at well-architected framework as well. Within that, 6 pillars. Within that pillars, we had best practices areas as well as best practices principles, right? So based on that, it gives us recommendation, right? The trusted advisor looks at the entire AWS environment, our environment, as in whatever we have configured, and give us real-time recommendation in 5 categories, which are cost optimization, security, performance, and a couple of more, two more things, that is, right, fault tolerances and service limits. Right, we can use AWS Trusted Advisor to help optimize our AWS environment as soon as we start implementing our architecture designs, which we have used AWS well-architected framework to design. Module final wrap-up. In summary, we looked at what AWS well-architected framework is, including the 6 pillars, right? Identified the design principle of AWS well-architected framework, explained the importance of reliability and high availability. So we looked at what reliability is, what high availability is as well. Reliability is basically, is the system reliable? As in, is it performing? Is it servicing? In a very simple sense, it is servicing the customer as it's supposed to service. High availability is the system available all the time, right? High availability and reliability is measured using a statistical measure called MTTF, MTBF, and for high availability, we looked at common applications and sort of acceptable limits. For availability, it is usually measured over the available time over it is supposed to be available, the total time over what it was available, right? That kind of calculation we do there. Trusted advisor helps customers, and it gives recommendation which tells us to follow the, based on the best practices that AWS has recommend, right? Interpret AWS trusted advisor recommendation. We did look at a few couple of activity remaining. We will try and do in the lab, right? Don't forget to do your knowledge check, exam question, sample exam question. A SysOps engineer working at a company wants to protect their data in transit and at rest. What services could they use to protect their data? Right? Now, what will be the answer? You have four choices: elastic load balancing, Amazon EBS, that is elastic block storage, Amazon S3, that is simple storage services, or all of the above. I hope, okay, I hope you have, answered. A few of you answered actually. Yes, it's D, isn't it? Right? SysOps engineer, whoever he is, working at a company, wants to predict their data both at transit, in transit, and at rest. Right? What services they use to protect their data? They use to protect. Now, these are for data at rest, right? These are storage services. Basically, data is in store unless someone is transferring data between them. They are at store, they're at rest in a way, they're storage, right? And this elastic load balancing is moving data between, healthy and unhealthy resources. That's what load balancing does, right? Based on what criteria we have defined. So both at in transit, at rest. So all of the above applies here. Yeah, the keywords in the question are protect data in transit and rest. Right, correct answer is D. Here is additional resources and